Hindi niyo ko signal.
Bigla rin ako.
Ma'am, sabihan mo sila, baka masisigaw sila. Sensitive kasi itong mic ko.
Eh, maglalag ka na.
Hey, good morning, good day to everyone. Welcome to Marina's Powerhouse Team Review and Training Center. So this is about the study of electrical engineering. So we are on day 4 of our study, electrical engineering. So this is a continuous study about the basic principles, from the basic up to the moderate and up to the complicated part of our study in electrical engineering. So, welcome, good day to everybody. Let's hear it from our Filipino audience in our Zoom. So please bear with us that I'm not that fluent in speaking the language. So we just have to speak this language so that our non-Filipino audience may understand our lecture, our lesson for today. So our topic is about electrical principles. This is actually part 4. Okay. May I see our Filipino audience there? Okay, to all our non-Filipino audience, actually this is a virtual classroom via Zoom. So you may see our audience here. So nakikita na ba? Yung estudyante dapat nakikita. Okay, so this is a live presentation. So today is August 14 and 10:08 a.m. Philippine time. Okay, so hello, good morning to our Filipino students, our Filipino participants, audience. Good morning, everybody. Good morning, good morning. Please bear with us. This is a live presentation. So, magandang umaga sa inyong lahat. Mga kawerpa, good morning. Can I hear you? Please. Marlo, good morning. We are on live, on YouTube live, no? Good morning. Net, nakikita ba yung audience natin? Dapat nakikita sila nung ano. Ha? Nakikita sila. Nakita sila sa YouTube. Nakikita sila sa YouTube, ha? Okay. Okay, good morning, everyone. Good morning, Marlo. Good morning, Sir Joey. Good morning. Okay, so this is a live lecture about electrical principles. So let us start our discussion. And to all non-Filipino participants for today or viewers, this is a live stream lecture about electrical principles. We'll be discussing about resistance, about Ohm's law, about power, energy. We'll be talking those topics for today. So please bear with us. I'm not that fluent in speaking the language, the English language. So I'm a Filipino, 100% Filipino. So we just want to help the students around the world. Okay, let us start our lesson for today. Focus tayo. Okay, let us continue our discussion about electrical principles. Ma'am, monitor mo kung naririnig mabuti. Okay, let us start. If the specific resistance of manganene is 41.8 microohm centimeter, what is the diameter of the manganene wire? 68.7 meter long, which has a resistance of 8.86 ohm. Okay, we have the basic formula for resistance. Our resistance is equal to rho L over D area. So we are given already the resistance. So let us substitute the resistance. We have 8.86 ohm. Then the resistivity is equal to 41.8 micro. Micro is times 10 to the negative 6. That is ohm, centimeter. Okay, then our lead. So we have the lead given 68.7 meters. 68.7 meters. Long, which has a resistance. Okay, we have already have the resistance here. And then what about now the area? The area of the conductor simply, so let's say this is our conductor. The cross-sectional area actually is a circle. So what is the area of a circle? The area of a circle is pi r square. So pi r square, so we have here pi, then our r is simply the diameter over 2, then quantity square. So we'll be having here pi. Okay, so we have here pi. 2 squared is simply 4. 2 squared is simply 4. That is over 4. And then we have d squared. So pi over 4 d squared. And then we have to multiply this by pi over 4. That is the area. So we have here pi over 4. We have diameter square. And then you will see here that the unit here is in centimeters. So let us convert this into centimeters. So we have what there are 100 centimeter per meter. Okay, so then this will be cancelled out. So this is meter and meter. Okay, so the only unknown here is our diameter d. So that's easy to solve in our calculator. So just make this shape solve in our calculator. By the way, we are using this calculator model in preparation for the licensure exam here in the Philippines. So this is, we are using the Casio FX 570 ES Plus. Casio FX 570 ES Plus. So this is allowed in the Professional Regulation Commission for the licensure exam. So let us manipulate this. Well, if you don't have this calculator, you have to manipulate this one by one, this equation. So, but using this calculator, we call that as shift solve. So just input 8.86, then alpha calc, no? For those who has this calculator, will you input the values here also? Do this also in your sheets there. So we have 8.86, 41.8. So just press times 10 to the x, negative 6. Okay, we have times 100. Okay, let's go over with our PowerPoint. Okay, Okay, what is the answer? Oh, mga kawerpa, ano sagot natin? What letter? Okay, the answer is 0.02, 0.20314433312. Right? Nakuha po ba yan? Okay, the answer is letter B. Let's go over with problem number 2. Okay, for problem number 2, a 15.3 meter strip of nichrome wire, 0.635 centimeter wide, has a resistance of 5.16 ohms. What is the thickness of the strip? So the question is the thickness of the strip. Okay, so we have again the formula for resistance. So we have this value, this formula, I mean, resistance is equal to rho L over A. Resistivity, length over the area. Okay, so let us put here the resistance. We already have the resistance. That is 5.16 ohm. Then the resistivity. Do we have the resistivity for that particular problem so that we can solve that? I think there should be a resistivity. Okay, so the assumed value for the resistivity, I'll just write it down. The assumed value for resistivity is 109. This is 109 times 10 to the negative 6. That is micro ohm centimeter. Micro ohm centimeter. Okay. That is the resistivity. What about now for the length? The length is 15.3 meters. 15.3 meters. And then we have to multiply it by 100 centimeter per meter for the conversion. Okay, so rho L over the area. So what about now for the area? Okay, so we are given here a strip. Take a look here, guys. We have a strip here. Okay. Geometrically, this is what we call a parallelepiped. No? So we have a shape of parallelepiped. This one. Let's say that is the strip. Okay, so we have a certain width. This is the width. And this is the thickness. That is the thickness. Okay? That is the thickness. We have the width, and this is actually the length. From this point up to this point. This is the length. Okay, so this is not a cylindrical. It's like our example before. This is a parallelepiped. So, what is the area here? So, the area here, since the question is what is the thickness? So, the thickness is simply equal to the width multiplied by the thickness because this is a rectangle. Okay? So, we have the width. What is the width? The given width is 0.635 centimeter. So we have 0.635 centimeter. And then multiplied by, so we have the thickness T. Okay. So let us shift solve this. What is the answer? Okay. O sige, kayo na pumindot dyan sa calculator ninyo. O, mag-unmute kayo. Ano sagot natin? Para merong audience participation. Okay, everybody, come on. So that our viewers will see that this is a live virtual classroom. No, we are on a live stream in YouTube. So what is the value for the thickness? Give me the value. May value na ba kayo dyan? Okay, so our answer is what letter? That is 0.051. Okay, did you get that also? 0.051, that is 0.051 centimeter. Okay, did you get that? Nakuha po ba? Ma, naririnig yung pukpok sa baba. Naka-off ako. Ino-off ko yung mic ko dito. Naririnig ko. Sensitive kasi itong mic ko. This is microphone. May link na tayo niya sa Facebook. Okay, so let us go. The answer here is letter A. So let's go with number 3 problem. Okay. So nakuha ba? Nakuha ba? Marlo, naririnig ako dyan na maayos sa lugar mo. Okay, sige. So, let's have number 3. Okay, number 3, determine the resistance of a conductor. So, 0.1 meter long. Okay, paki-close up pang mabuti. Determine the resistance of a conductor 0.1 meter long with a uniform diameter of 1 centimeter and having a resistivity which varies as a function of length L measured from one end of the conductor according to the formula. So we have rho that is equal to 0.003 plus 10 to the negative 4 L squared ohm centimeter. Okay, so let us solve this problem. So we have here the formula. What is the basic formula? So we have R that is equal to rho L over the area. So this is our basic formula. We can also have this formula. R is equal to 1 over the area. Okay, that is the integral of rho, resistivity, then the differential length. Let's say from initial to final length. Okay, so we are given here the length of 0.1 meter. So our length is equal to 0.1 meter. So let us convert this into centimeter. Since the resistivity is in ohm centimeter, that is the unit. So we have here 100 centimeter per meter. So we'll come up with, so we have 2 zeros here. So we have 1, 2. So the answer is 10 centimeter. So let us substitute this value. So we have here 1 over, so this is pi over 4. What is our diameter? So that is simply 1 centimeter. So we have 1 squared. And then we have the integral of the resistivity. So we have the resistivity of 0.003 plus 10 raised to negative 4. Then we have L squared dl. Okay? And then what about now for the limit of this integral sign? This is from 0 to 10. Okay. So we have here r that is equal to what will happen here. Algebraically, this will go up here. So our 4 will be our numerator and the pi here will be our denominator. Okay. Then we have the integral from 0 to 10 of, oh, by the way, we can already get the integral of this portion of this. We can get the integral of this. Okay. What is the integral of 0.003? Let us get the integral of this. So we have what? 0.003. So we have to distribute our DL. Integral of DL simply equal to L. And then plus 10 raised to negative 4. Okay, what is the integral of L squared DL? Okay, by power formula in integral calculus, so we have to make this as L. Okay, L cubed. So you have to put here 1. Okay, and then this is over, this is 3, this is also 3. That is over 3. Okay, and then we have the limit from 0 to 10. Or just simply, you just have to substitute 10 here in our L. Okay, just substitute 10 in L. So what will be the value for this? What is the value? Although in our calculator, we can go directly with our calculator, no? You input this in your calculator, we have integral sign in our calculator. So, okay, to our viewers, we are using this calculator. This is Casio FX570 ES Plus. Okay, so this is allowed by the Professional Regulation Commission. Okay, to our non-Filipino audience, so good morning, good day to everybody. Whatever the time you watch in your country, of course, we have different time zones. So good day to everybody. So we are using this calculator model from time to time. We'll be using this calculator. You're going to input all the values, no, and then this calculator will solve easily. Even you have an integral, just like this. Okay, everybody, you press our integral sign. That is below the button alpha. Okay, then we have to input 0.003. Just input 0.003 plus 10. 0.003 plus 10 to the negative 4. It's better you press first 1. 1, then times the button times 10 raised to x. The 10 raised to x is below the number 3. Below the number 3. So you press 1 times 10 raised to negative 4. Okay. So we have variable. Instead of L, put here variable x. So you press alpha, then close parentheses, then you press now x squared. And then close parentheses. Okay, then you input now the limits. So we have the limits from 0 to 10. 0 to 10. By the way, we have to, okay, so equals, and then we have to multiply it by 4, then divided by pi, equals. So my answer here is 0.0806. I hope you see the display in my calculator. So that is the answer. Please close up this one. So our answer is 0.0806385.045. Okay, did you get that? Everyone, everybody, did you get that? Okay. So you just have to practice. Okay. So we have next number. What is the letter of our answer? 0.0506. The answer would be letter. Okay. So we have letter C. That is our answer. Okay, let's go on to the next topic about insulation resistance. Let's go over here. Yan ba yung cellphone ko?
Wala kay Kenji po.
Hindi mo kailangan ko. Okay, so we have the insulation resistance of a conductor. Okay, so insulation resistance. Okay, so we have this formula for the insulation resistance and the symbol R. So that is rho resistivity over 2 pi L over 2 pi L, then the natural logarithm of R sub 2 over R sub 1. So that is our formula. Okay, so what is our R sub 2 over R sub 1? So let us consider we have a conductor here. Okay, so it has an internal diameter. This is the internal diameter. Okay, that is the internal diameter. Then we have here the, let's say the outer diameter, that is including the insulation. Let's say this is the thickness of the insulation. Then this is our R sub 1. That is the internal radius. Internal radius. And this is our R sub 2. R sub 2. Which is equal to the internal radius plus the thickness. That is our R sub 2. Okay, so we are given here in our problem that a certain wire has a conductor with a diameter of 0.5 inch. So this is the 0.5 inch. 0.5 inch. And a 0.15 inch thick. So this is 0.15 inch thick. This is the thickness of the insulation. Wrap around the conductor. So you're given the specific resistance already. Okay, so what is the insulation resistance per 1,000 feet length? Per 1,000 feet length. Okay, so let us get first our R sub 2. What is our R sub 2? Here, so we have here R sub 2 that is equal to R sub 1 plus the thickness. Okay, so what is our R sub 1? Our R sub 1 that is equal to, we have the diameter, okay, then we have to divide it by 2. We have a 0.5, 0.5 divided by 2. So we'll come up R sub 1 that is 0.25, isn't it? Because this is 0.5, so we have 0.25. And let us substitute R1 0.25, 0.25, then plus the thickness. What is the thickness? That is 0.15. Okay, so this will become 0.4. Okay, so that is our 0.4. 0.4 inch. So we are now ready to substitute all the values for the insulation resistance. We have the insulation resistance that is equal to 1 times 10 to the 14 times 10 to the 14, that is ohms centimeter. Okay. And then we have 2 pi. Remember that this is ohm centimeter. 2 pi. Then we have here 1,000 feet length. 2 pi L. So we are given here the length as 1,000 feet. 1,000 feet. Okay. So this is the 1,000 feet now. Remember that this is centimeter, this is in feet. So we have to convert our length here, by the way, by centimeter. Okay, so may I put here our length first before I substitute here. So I will erase this 1,000 feet. So we have a 1,000 feet. Okay, so we'll erase this one. So we have 1,000 feet. Okay, so we have here 12. There are 12 inches per foot. Okay, so our foot or feet unit will be cancelled out and then multiplied by. There are 2.54 centimeter per inch. So our inch will cancel out here. Okay, so let us manipulate the length. What is the value for our length? Here. So let us calculate this, guys. What is our length? We have 1,000 times 12 times 2.54. That is equal to, okay, 30,480. 30,480. So that is in centimeter. So that is the length. So just put here 30,480 centimeter. 30,480 centimeter. Then the natural logarithm of R sub 2. R sub 2 is 0.4. 0.4. Then divided by R sub 1. R sub 1, which is 0.25. We have 0.25. So what will be our insulation resistance here? So let us calculate. Okay, we have 1,000 times, oops, we have 1 1 to the exponent 14. Okay, and then divided by 2 pi. We have 30,480. Okay, then we have here the natural logarithm. Let's press the ln. We have 0.4. Okay. Point 4 over 0.25 equals. So the answer is 245. What's this? Let us write this down. This is too long. So we have here 245, 245, 417, 417, 417, 981. 981.8. So that is the display in my calculator. So our choices here, please go over here to our PowerPoint. Okay, that is expressed in 10 to the 8. So we have to manipulate this, no? We have to move the decimal places going to the left. So we have here 1, 2, 3, 4, 5, 6, 7, 8. So the answer will be 2.45. Let us round it off this one. That is 2.45 times 10 raised to 8. That is our answer. Okay? That is the insulation resistance of the conductor. So the answer would be letter C. That is our answer. Okay? Nakukuha nyo ba dyan? Clear ba? Nakakasunod tayo. Okay, let's have now the Ohm's law. Although we already discussed Ohm's law before, but let us have some basic calculations on Ohm's law. I will add some discussion here. So, what is a graph of a Ohm's law curve? What is a graph? So, let us have here the x and y axis. Theoretically, the graph of an Ohm's law curve is straight line. This is a straight line. Okay, there is a licensure exam. It was a question of, this question is, what is the slope? What is the slope of the Ohm's law curve? What is the slope? Okay, letter A, voltage. Letter B, resistance. Letter C, current. Letter D, power. What is the slope of the Ohm's law curve? That is the question. Okay, so in here, our x-axis. So we have here our y-axis. Okay, so we have our voltage V, then our current I here. Okay, so as I've teach you before, so our Ohm's law states that the current flowing in a circuit is directly proportional to the voltage and inversely proportional to the resistance. That is the Ohm's law. Okay, I is equal to V over R. Now, what is the relation of the voltage to the current? As we increase the voltage, the current also increases. That is the relation. Okay. But if we lower the voltage, the current also lowers. It decreases also because they are directly proportional, the current and the voltage. And then what is the relationship of the resistance to the current? Of course, they have inverse relationship. So as the resistance increases, what happened to our current? It decreases. As the resistance decreases, what will happen to our current? It will increase. Okay? So, let us increase our resistance. Okay? So that the flow of virus will decrease. Right? Just like in human, no? We as human, if we have a very good resistance, no, we are healthy. We always drink our vitamins, especially vitamin C, to increase our body resistance. Okay, the flow of this COVID virus will decrease. Okay, so just like also in Ohm's law, as we increase the resistance, the current flow decreases. Now, take a look at the Ohm's law graph. The Ohm's law graph is linear. Theoretically, that is linear. You can even try in an experiment. Then you have to plot this. And then we found out in the university, we are performing this experiment. As we increase the voltage, the current also increases. As we increase the voltage from 0 volt to 10, 20, 30, up to 100 volts, the current also increases here. Now, the question in the licensure exam is what is the slope of the Ohm's law graph? What is the slope? So, take a look. Letter A, voltage, then resistance, is that current, is that power? That is the choices. Okay? So, what is our slope? The question is, what is the slope of the Ohm's law graph or Ohm's law curve? The slope, we all know the basic formula is the rise over the run. That is basic, right? What is our run? What is our rise? Our rise simply at a particular point, the rise of this point corresponds to the voltage. Voltage. What is the run? The run corresponds to the x-axis. This is the run. This is the run, the rise over the run. The run is simply the current. By Ohm's law, what is the voltage over the current? Marlo? Will you spotlight Marlo? What is the answer in this licensure exam, Marlo? Voltage over current. What is that? I can't hear you, Marlo. Please speak louder. Please unmute. Please unmute. Hindi ka namin naririnig. We can't hear you. Okay. So, anyway. Okay na. Balik mo na dito. Anyway, so our answer here is, what is voltage over current? That is simply our resistance. That is the answer. That is the slope of the Ohm's law curve. That is the resistance. Okay? That is the resistance. Let us have some basic calculation. This is a very easy topic, no? You can easily understand this topic about Ohm's law. But this is the most important law in electrical engineering, the Ohm's law. Okay, there is what we call a triangle. So we have a triangle here. This is our V, this is our I, and then this is our R. If we are to get our voltage, what will be left is what? Okay, let us put our hand, I'll put my hand here. What will be left is IR. So V is equal to IR. Isn't it? What about for I? Okay, our I is, what will be left is V over R. That is V over R. What is our resistance? Our resistance is simply the voltage over the current. Voltage over the current, which is the slope of the Ohm's law graph. Okay? Again, just like what I have told you before, if this is the free electrons and these are the charges, these are group of free electrons. If I will push this with my finger, the force on my finger is the voltage. That is the voltage. And then the flow, the rate of flow of this charge from this point up to this point is what we call the current. Remember, the one flowing is the charges or the free electrons, not actually the current. That is just conventionally used all over the world. But for me, that is wrong. I already explained that before. Why is it wrong? Why current flow, the word current flow is wrong? Although, of course, I'm also using that when I teach in the university. Because that is the conventional, that is the traditional way of saying it. But actually, the one flowing is the charges. Because current, again, current is the rate of flow of charge. This is charge per unit of time. Just like the speed. Just like the speed. Okay? The one that travels is the car. Okay? So you may say the flow of the vehicle. You cannot say the flow of the velocity. That's wrong. The velocity is distance per unit of time. If that is per unit of time, that is already the rate. See, that is the rate already. So it's better to say the charge flow or the electron flow, okay, rather than current flow. No? Well, of course, me also, I am using most of the time the current flow because that is already using. That is a conventional way of saying it, the current flow. Okay, but actually the one flowing is the charge or the free electrons. Okay, so let us go over with our basic calculations. Let's go over here for number 5 problem. Number 5. Find voltage V when current I is 3.5 ampere and resistance that is equal to 20 ohms. So this is easy. What is our unknown voltage V? So our formula for V is simply equal to, we already have that formula here, so that is IR. That is IR. Okay? This is IR. Okay? So our I is equal to 3.5 amperes times the resistance, which is 20. Okay? 3.5, what is 3.5 times 20? Okay, so we have 3.5 times 20, that is actually 70 volts. So we have here 70. That is our voltage, 70 volts. Okay? So let us have now number 6 problem. Okay, number 6. We have, okay, the answer for number 5, 70 volts, that is letter D. Okay, for number 6, find resistance R when V is 220 volts and current I is 11 amperes. Okay, so the question is the resistance. So we have our resistance that is equal to voltage V over the current. So we have here our resistance that is equal to 220 volts over I, which is 11 amperes. What is 11, 220 divided by 11? That is simply equal to 20 ohms. 20 ohms. Okay, the answer would be letter. Okay, so letter C. Okay, that's very easy. Okay, very easy. Okay, number 7. Okay, number 7. So find I when V is 120 volts and R is 30 ohms. That is the resistance. So we have here our I that's simply equal to V over resistance. So we have here for our I, what is the voltage? 120 volts over the resistance is 30 ohms. 30 ohms. Okay, so we'll come up with 4 amperes. That is the answer. 4 amperes. Okay, the answer is letter. What letter is the answer? Letter B. Okay. So let us have now electrical power. Okay, so what is electrical power? So let us discuss the basic of electrical power. We have here, it is defined as the rate at which electrical energy is expended or used up. It is the rate of electric energy is converted into another form, such as light, heat, or mechanical energy, or converted from another form into electrical energy. Okay. So, power, that is basically the rate of doing work or the rate of converting the electrical energy from one form to another. Okay, so there is a scientific law that says that is the law on conservation of energy. Energy cannot be created nor destroyed. It can only be converted into other forms of energy. Okay, remember that. Energy cannot be, is there a word cannot be created? I disagree. Because God created that. The energy, God created energy. It cannot be destroyed. It just, we are just convert this energy. Let's say, electrical energy into mechanical energy. Electrical energy into, let's say, chemical energy. Into light energy. Whatever forms of energy. But it cannot be destroyed. Okay? You see, there is a motor, there is a, in power plant, there is a turbine. You see, this is a steam turbine, turbine. What is the correct pronunciation? Simulations, simulation. Okay, so we have here a generator. Okay, this is the generator, the turbine and the generator. Okay, so there is a mechanical energy here. This is a mechanical energy. This rotate. Okay, I will destroy this energy. Huh? I will hold this coupling of the turbine and the generator. I will stop that turbine. No, you can't do that. Or else you'll be stuck. No? That is very dangerous to your hand. Okay? So, you cannot destroy energy. You just convert this energy. Okay? I disagree. Energy cannot be created nor destroyed. Cannot be created by men. It is created by God. No? Okay. So let us have the basic unit of energy or power. Watt. It is the unit of electrical power named after Scottish engineer James Watt from 1736 to 1890. So these are the different formula for power. Power is equal to VI, voltage times current. Power is equal to V squared over R. Power is equal to I squared times R. Okay? The basic unit of power is watt. Okay, so we have a watt. Let's say we have 1 watt. What do we mean by 1 watt? 1 watt is simply equal to 1 joule per second. 1 joule per second. Take note that 1 watt, that's equal to joule per second. This watt is power. The joule is energy or work. No? Energy is synonymous to work. And second is time. That is the rate of doing work. If we mean rate, that is divided by the time. If we mean the rate. Okay? That is divided by the time. 1 watt, 1 joule per second. And 1 joule, a unit of energy or work, 1 joule is equal to 1 Newton meter. 1 Newton meter. That is 1 joule. That is 1 Newton meter. Okay? That is the basic of power. Then take note here that 1 horsepower is 746 watts. 1 kilowatt is 1,000 watts. 1 megawatt is 1 million watts. Okay, let us have some basic calculations. Number 8 problem. How many kilowatts of power are delivered to a circuit by a 240 volts generator that supplies 20 ampere to the circuit? Okay, so there is a generator. How many kilowatts? To be specific, it is a DC generator. So how many kilowatts of power being delivered by the generator? So we have simply the power. Again, power is equal to voltage times the current. That is our formula. So our power, what is our voltage? We have 240 volts. 240 volts. Then what is our current? 20 ampere. Okay. So we have here our wattage. Let us multiply this 240 times 20. That is 4,800. 4,800 watts. Okay, so 1 kilowatt, there are 1,000 watts. So the watts will cancel out. Okay, here. So you just have to divide. Or, it is easier, so there is a decimal point here, right? Just move the decimal point here. Since this is kilo, that is 3 times going to the left. So we have here 1, 2, and 3. So this will now be the new place of the decimal point. So therefore, the answer would be 4.8 kilowatts. Okay, 4.8 kilowatts. So the answer is letter. Okay, we have letter A. Huh? That is letter A. Number 9 problem. Number 9. Okay, number 9. Let us read the problem. The current through a 100 ohm resistor to be used in a circuit is 0.2 ampere. Find the power rating of the resistor. Find the power rating. So, the power, since we are given the resistance and the current, what formula are we going to use? We have the current, we have the resistance, therefore, it is I squared R. Okay? So, we have the power now that is equal to 0.2 ampere. That is quantity squared and then multiplied by the resistance, which is 100 ohm. Okay, so let us solve this one, 0.2. So the answer is 4 watts. 4 watts. Okay, that is our answer. So remember that power, okay, let's go back again. That power is the rate, that is the rate of converting the energy from one form to another. Okay? So that is the power. Take note here again. Let's go back here. If we have 1 watt to be 1 joule per second, so therefore, 1 watt simply equal to 1 Newton meter per second. 1 Newton meter per second. Take a look here. We have 1 watt. 1 watt, that is 1 Newton. I'll just make this as 1 Newton. This is 1 Newton. What is meter per second? There is a meter per second. Therefore, what is watt? That is a power. What is this one? Force. The Newton is a unit of force. Then what is the meter per second? This is our velocity. Isn't it? Did you get that? So therefore, the power is equal to the force times the velocity. This is another formula. Okay? That is being studied in physics. Okay? So, power is force times the velocity. This is the principle being used by Manny Pacquiao. Don't you know that? Why, sir? How is that? What do you mean by that, sir? You see, sometimes the sportscaster, no, when there is a live fight of Manny Pacquiao. By the way, a good day to all our viewers, to all my fellow Filipino and my fellow non-Filipino viewers. A good day to everybody. So we are discussing the principles of electricity. We are on part 4, no, for our late tuners, late viewers. Okay, so this is studying electrical engineering the Filipino way. No? So my name is Engineer Reggie Marinay from the Philippines. No? If we have, because last night I just saw some foreign nationals looking at my lectures on my YouTube. So hindi lang tayo pang Pilipinas. No? We are not only for Filipino audience. No, we are, since this is YouTube, this is for global audience, no? For our students all around the globe, no? So this is because we want to help you guys, no? We want to help everybody, our fellow men, especially this time of pandemic, no? Okay. What did I say? My name is Engineer Reggie Marinay. Okay, so I'm from the Philippines, no? I'm discussing Manny Pacquiao. I'm from the Philippines, the land of Manny Pacquiao and Catriona Gray, Pia Wurtzbach. Okay, so actually I saw some Indian nationals looking at my lectures in the YouTube. Thank you very much. If there are any viewers who are non-Filipinos, good day to you, everybody. Good day, everyone. So I hope you are safe right now. Okay, let us continue our discussion. What did I say from this formula? This is the principle being used by Manny Pacquiao. How is it? You see, the sportscaster would say, he would say, look at the speed, no? The explosiveness, the power. See, the sportscaster would say that during his fight. This is the principle being used by Manny Pacquiao. How? This is a force times the velocity. Of course, you see the force of Manny Pacquiao, that's a very large amount of force. I saw Manny Pacquiao's YouTube. Is in the mall. There is a game there, no, punching, and that measures the force of a punch. No, his force is too high for every punch. It's a very large amount of force exerted by Manny Pacquiao, especially the left. No, he's a southpaw, right? And he applied this, the velocity, large force, and he punched too fast. See, he punched too fast. His punches, he throws a lot of punches at any angles, just like the late Mike Tyson said. The late Mike Tyson said, Floyd has to just to fight. You see, Floyd Mayweather during those fight. What year was that? 2015. Floyd Mayweather is just like that, like that. You see, just punch like that. But Manny Pacquiao is attacking him. But he won the fight. I disagree. I saw in the YouTube, there are a lot of YouTube fights, no, being done by non-Filipinos. They believe that Manny Pacquiao won the fight because Manny has a large amount of force exerted from his especially left hand, and he has a very fast hand. The force and the velocity correspond to the power. There is power. Okay? You can sleep. Okay, go to Manny Pacquiao. If you have the problem of sleeping, okay, let's continue. What number are we now? Okay, so we have number 10 problem. If the voltage across a 25,000 ohm resistor is 500 volts, what is the power dissipated in the resistor? Okay, number 10. If the voltage across, okay, actually we are given here the voltage and the resistance. What is the power dissipated? What is the formula if we have the voltage and the resistance? So the power simply equal to the V squared over R. So we have here the power that is equal to, what is the voltage? 500. 500 squared, then over the resistance of 25,000. There you are. So our T is equal to what? Let us calculate this. The answer is simply 10 watts. 10 watts. Okay, the answer would be letter, letter C. Okay? So let us have number 11. How much energy is delivered in 2 hours by a generator supplying 10 kilowatts? Okay? So 10 kilowatts. Remember here in our choices, because in our licensure exam here in the Philippines is a purely multiple choice. So that's very good. You have already a hint how to, if you are right or wrong in your final answer. No? Okay, so we have here kilowatt hour. So therefore, we just have to multiply the kilowatt into hour so that you can get now the energy. Okay, remember that the energy is equal to the power multiplied by the time, times time. Because power is energy divided by time, isn't it? If I will make this as energy, this is over time. This is the rate of doing work or rate of converting the energy from one form to the other. Okay? So, let us get now the energy. We have a power, P, 10 kilowatts. So, just put here 10. This is the kilowatt. What is the time? That is 2 hours. Okay. So, the energy now will be equal to, okay, that is 20 kilowatt hour. 20 kilowatt hour. Okay, the answer is letter A. Okay, did you get that? Let's go over to number 12. Number 12. Oy, pakibukas naman yung ano. Ay, hindi pala akong naririnig nito. Okay, to our Filipino audience in the Zoom class. Okay, so please open your video. It is required, no, for us in the Zoom class, no, so that our non-Filipino audience may see us, no, in the Zoom. So please open, and Ricky, please open. It's part of the our policy. So please, so that we can give you the para bigyan namin kayo ng ano, ng certificate. And you will have a chance. You will have a chance for the 50% or 100% scholarship in the review program, regular review program of Powerhouse for April 2021, REE or RME licensure exam. No? So please open. So we will continue our discussion for number 12 now. Okay, so we have find the efficiency of a motor which receives 4 kilowatt and delivers 4 horsepower. So take note here that we have a question here for the efficiency. Okay, for number 12, what is efficiency? Efficiency is equal to power output over power input times 100%. That is the efficiency. Now, we should have the same unit for power output and power input. So it says in the problem here, find the efficiency of a motor which receives. This is the power received by the motor and delivers. Okay, for example, I will discuss this. Let's say this is our motor. Okay, this is our motor. In our motor, there is an input power. That's always. We have a power input. This is our power input in our equation. or the efficiency, power output over power input. But where is the power output? Where is the power output? This motor drives a certain mechanical load. So it drives a mechanical load. We have this. So there you can see our power output that is found on the shaft of this particular motor. This is the power output. The power input is important in sizing your wires, your protections, your cables, your relays. Okay? We have the formula for I that is equal to power over voltage. This is very important formula in sizing your wire and your protections. You just have to know power. What kind of power is this? You have your motor. Is that the input or the output power? This is actually the input power. Remember that. That is the input, not the output. Not the output. Not the output. Okay. So, we have here given which receives. So, it receives 4 kilowatt. So, the 4 kilowatt is your power input. 4 kilowatts. Delivers 4 horsepower. So, this is our 4 HP. 4 horsepower. Power output is 4 horsepower. That is the output. Okay? So what now? Let us have the power output. The power output is 4 horsepower. Let us multiply this, okay, by 746 watts per horsepower. Okay, and then the horsepower will cancel out. What is our power output? Okay, let us calculate this one. Okay, we have 4 times 746. So that is 2984. 2984 watts. Okay, I will make this in kilowatts. So you just have to move the decimal point going to the left 3 times. 1, 2, and 3. Okay, then we have here power output to be 2.984 kilowatts. Okay, and then let us solve this one. This efficiency. Okay, our efficiency here is equal to what? What is our power output? What is our power output? We have 2984 or 2.984 kilowatts. Power output. What is the power input? We have 4 kilowatts. Okay? We have 4 kilowatts. Simply 4 kilowatts. So this is times 100%. So the efficiency now will be equal to 2.984, then divided by 4. Well, it's simply 0.746, or to round it up, that is 75%. Okay, I'll just make this as 74.6%. That is the efficiency. Okay. Let us go over here. The answer will be letter C. Okay? Letter C. Okay, let's go now to problem number 13. Okay, problem number 13. Let us read. The motor in a washing machine uses 1,200 watts. How much energy in kilowatt hour is used in a week by a laundromat? Laundromat. What is a laundromat? Actually, this is a term in US. Although we are not in US, no? So, this is an establishment in America wherein you can put your laundry. This is a coin-operated laundry machines. Okay? How you pronounce this? Laundromat? Okay? Whatever. Okay? So, how much energy in kilowatt hour is used in a week? Meaning for 7 weekly, I mean, by a laundromat with 8 washers. 8 washers meaning this correspond to our motor. There are 8 motors, the washers. You see, not the washer in the bicycle, not the washer. Okay? This correspond to the motor. If they are all in use for 10 hours per day or 6-day week. Okay, again, the question is the energy in kilowatt hour. So we have here energy. Again, what is our energy? Energy is power times time. Power times time. So our energy is equal to, we have to know our kilowatts. Okay? We have 1,200 watts. This is the wattage of the motor in a washing machine. 1,200 watts. Okay? But how many motors do we have here? This is watts. You see? Let us read again. The motor in a washing machine uses 1,200. Meaning, in a washing machine, meaning there's only one washing machine. Meaning, one motor per washing machine. The motor in a washing machine uses 1,200 watts. But how many washers or washing machine do we have? Or motors do we have? In the problem, it says here 8 washers. So put here 8. Well, we may say that this is 1,200 watts per motor if we want to become more specific. Okay? And then there are 8 motors. Okay, so this will cancel out. That is just the watts. Okay? Watts. What about the hour? Well, if we want to consider the conversion, so 1 kilowatt, there are 1,000 watts. What about now the hour? The hour is 10 hours per day. So we have 10 hours per day. Okay, then we have to multiply it by 6 days. 6 days for a week. Okay? So let us cancel out. The motor unit will cancel. The day will cancel. Okay? Of course, the watts will cancel so that what will be left here is the kilowatt hour. So let us multiply 1,200 times 8 times 10 times 6 divided by 1,000. The answer is 576. kilowatt hour. Okay, that is the answer. So what letter is our answer now? So the answer is letter A. Okay, letter A. So let's go over with number 14. Number 14. A radio receiver draws 0.9 ampere at 110 volts. If the set is used 3 hours per day, how much energy does it consume in 7 days? Okay, so we need to have a kilowatt hour as our unit. Okay, so our energy, again, that is power times the time. Let us get first the power. What is power? So we have 110 volts, that is VI, right? 110. Remember, this is in volts. Then multiplied by power is VI, so we have here 0.9 ampere. So that is already watts, right? We already have a watts here. The volt ampere here is already watts. Okay? So we may say here, okay, we'll come up with a watts, or let us convert this 1 kilowatt. There are 1,000 watts, where it is understood to be in direct current that watts is just simply the volt ampere. Okay? Although you will learn later that the watts is sometimes different in the volt ampere, that is in the alternating current circuits. But in DC, automatic, the volt ampere is also the watts. Just the same. Okay, so we have now the kilowatt. And then we have 3 hours per day. 3 hours per day. And then we have 7 days. The days will cancel out here. So we'll come up with kilowatt hour, isn't it? So this will be our energy. Let us calculate. 110 times 0.9 times 3 times 7 divided by 1,000. So my answer here is 2.079. 2 or 2 to round it up, 2.08. 2.08. That is the answer. That is in kilowatt hour. Kilowatt hour. No? Okay? There you are. Letter D is the answer. Letter D. Let's go over to number 15. Number 15. Okay, to our viewers, you may copy our question there. Okay, let us continue for number 15. Okay, for number 15, so we have 10 kilowatts is equal to how many calories per second? So 10 kilowatts. So 10 kilowatts is 10,000 watts. That is 10,000 watts because 10 kilowatts, no? 10 kilowatts, 10 kilo. So this is the watts. So the question here is equal to how many calories per second? Remember that our watts is joules per second, isn't it? Joules per second. I will replace the watts by joules per second because the question here is the calories per second. The calories per second. So we have to multiply this by what? Remember, there is a conversion here. Should be in calories per second. 1 calorie, there are 4.186 joules. That is the conversion. So the joule will cancel out here. So what will be left is this one, 10,000, 4.186 joules per second. This is 2388.915. 2388.915. Okay? That will be calories per second. That is the answer here. Okay, what letter is our answer here? 2388. So the answer would be letter B. Okay, remember those conversion. We have a lot of that. Okay? So number 16. Okay, you may copy our problem there. Okay, number 16. A certain generator has an output power of 10 raised to 12 erg. Remember, there is a unit here of erg per second. What is the output in kilowatts? What is the output in kilowatts? Okay, so we have here the output power of, I will put here 1 times 10 to the 12. Automatically, this 10 raised to 12 is automatically to be 1 times 10 to the 12 when you input that in your calculator. You input that. 1, then you will see in your calculator 10 raised to x. That is below the number 3. That is besides the ANS, ANS. Did you see that? Okay. So we have, that is actually the 10 to the 12 erg per second. There is a conversion here. This is the conversion. 1 joule, okay, this is 1 times 10 raised to 7 erg. That is 10 million, no? Okay, so we just have to calculate this one. The erg will cancel out, by the way. Erg will cancel out. So we'll be having the value 1 to the exponent 12. Okay, and then we just have to divide it by 1 to the exponent of 10 raised to 7. Okay. So the answer here is 100,000. Is that correct? 100,000. What is the unit? That is in joules per second. But what is joules per second, by the way? That is watts, right? The joules per second is what? That is the basic of power. Okay? So we have here 100, 1, 2, 3 watts. Okay? The question is in kilowatt. What shall we do now? Of course, we have the decimal here, move it to the left. So we have 1, 2, and 3. So simply, the answer here is, what will be our power? Our power is simply 100 kilowatts. Okay? Did you get that? Did you get that? The answer is letter C. Okay, everybody, did you get that? Okay, so we have here Jesus. Very nice name, Jesus. Okay, Jesus. Okay, so we have Mark. Okay, nakuha ba? Nakuha? This is spotlight so that our viewers may see them also, because we are conducting a live virtual classroom here. No? Okay, although we are not here in one room, but you are in we are on a digital setup, right? Actually, this is a digital setup. This is a virtual classroom, and we call this as a Zoom classroom. No? Okay, so I'm inviting everyone to go to join us in our Zoom classroom. Okay, so the advantage of this is for those who will be participating in our lectures, we will give you a certificate, no? If you are going to join us in our Zoom class. Okay, that is the advantage of these people, these students in the Zoom class we're in, and they can also have a chance to ask questions, no? Unlike in the YouTube or in the Facebook, so you don't have the opportunity to ask questions. No? But if you are in the Zoom class, okay, okay, students, participants, later we will have a question and answer portion. Get ready for your question. Okay, I still have how many problems to go? Four problems more. Okay, let us read problem number 17. Problem number 17. Okay, problem number 17. Okay, so we have 100 liters of water is heated from 20 degrees Celsius to 40 degrees Celsius. How many kilowatt hour of electricity is needed, assuming no losses? Okay, so there is a heat. No? You have to we have a water that must be heated from 20 degrees to 40 degrees Celsius. No? So, okay. So let us get first, I think I have to discuss the basic principle of a heater. I'll show this to you on the board. A water heater, it has an input and an output heat. Let us call this as heat energy, this topic. Heat energy. Heat energy. Let's say we have a container. We have a container here. Okay. So that is filled with water, maybe around 80% filled. Okay, then we have here our water heater. Okay, so we have the plug here. This is the outlet. I remember During my high school days, we made a water heater. We made a water heater from the slipper. And then we put a nichrome wire. I think it's a nichrome wire or coil on it. Okay, this one. So that is what we call an input heat. Let us call this as Q input. If there is input, there is output, of course. No? So we have here an output heat to boil our water. So there is output heat. You see the red one, that red one is actually represents the output heat. That is the output heat. So we have here the output heat, Q output, that's equal to MC delta T. Where M is our mass, the C is our specific heat, and that delta T is the change in temperature. Then we have the input heat. The input heat, this is 0.24, okay, power times time. Of course, this power, we all know already the three formulas for power, the VI, the V squared over R, the I squared R. Okay? Then let us have the thermal efficiency. Thermal efficiency. How to get the thermal efficiency? The thermal efficiency, we have this symbol, you know, this is a Greek alphabet, eta. Eta. Okay? Eta. We call this as, you know, there is a rho, okay? That is also a Greek alphabet. There is beta, that is ohms, that is delta, gamma. Those are part of the Greek alphabet. And this symbol is eta. No? In Filipino, if you reverse this, it's not that pleasant word to Filipinos. Okay? So, let's go over here. So, we have here the input, the output heat. Before I already teach you the efficiency, the electrical efficiency is the power output over the power input. Just the same for the heat energy. So this is the output heat divided by the input heat times 100%. Okay? So we can have for the input heat, this is the output heat plus the loss heat. That is the loss heat. Just like in our formula, the power input, okay, is equal to the power output plus power losses. Okay, just the same. This is for the heat efficiency, or the thermal heat, I should say. So, we can now solve this problem for number 17. Okay, for number 17, so we have 100 liters. We have 100 liters of water. So, heated from 20 to 40 degrees Celsius. How many kilowatt hour of electricity is needed, assuming there's no losses? No losses means 100% efficiency. Okay? Wherein our input is equal to the output heat. So, let us get first our mass. What is our mass? Our mass, we are given in our problem, we have, how much is this? What is our mass here? Take note, by the way, we have 100 liters. 100 liters. 100 liters. Don't you know that per liter of water, that corresponds to 1 kilogram. Or there is 1 kilogram of water per liter. Try to imagine there is a bottle of Coca-Cola. Coca-Cola bottle. There is a Coca-Cola bottle. Okay? The contain, if you fill this, what do you call that? If you fill up this 1 liter of Coke, of Coca-Cola, if you will measure the mass or weight that mass of water, that is 1 kilogram. Minus the weight of the bottle, of course. Do not include the weight of the bottle. Okay? So, this is very easy. 100 liters, 1 kilogram per liter. This will cancel out, right? So, we have now the mass to be 100 kilograms. That is 100 kilograms. Okay? So, 100 kilograms. So, we have the formula for our heat. Remember, if there is no losses, if no losses, what do we mean by no losses? Meaning the efficiency is 100%. We may say that the input heat is simply equal to the output heat. Remember that. But what is the formula for the output heat? The output heat is mc delta T. That is our formula. We just have to substitute. What is Q output? What is our mass? 100 kilogram. Where 100 kilogram. Let us put the unit here. What is the specific heat? Take note, 1 kilocalorie per kilogram per degree Celsius. But what is our change in temperature? We have 40 minus 20, that is degree Celsius. Okay, so you will see here that this will cancel out. The degree Celsius will cancel out. The kilogram will cancel out. What will be our kilocalories? What will be our Q output here? Okay, let us calculate the kilocalorie. Okay, so we have here 100 times 40 minus 20, simply 20. So we just have here 2,000 kilocalorie. 2,000. Right? That is 2,000 kilocalorie. Then let us convert this one. 1 kilowatt hour. Remember this, 1 kilowatt hour, there are 860 kilocalorie. There are 860 kilocalorie. So the kilocalorie will cancel out. The output heat, which is equal to the input heat. So simply equal to, we just have to divide this one. We have 2,000 divided by 860. So the answer would be 2.325581395. Is that correct? 2.32, 2.32 kilowatt hour. So this is our heat energy. Heat energy. So the answer would be letter A. Okay? Letter A. Can you follow, everybody? I hope you can follow. Okay? So let us have now number 18. Okay, you may copy, or it's better you may screenshot or picture on your screen. Take a picture so that you will not write it anymore. No? It takes a lot of time. Then you read now. Let us read this problem or number 18. Okay, for number 18, we have 2.3 kilowatt hour is expended to heat 100 liters of water inside an insulated vessel. What shall be the rise in temperature in degree Fahrenheit? So the question here is in degree Fahrenheit. Huh? Degree Fahrenheit. That is an English system. Okay, earlier we have a metric system. So let us solve this number 18. We have here 100 liters of water. Okay, let's go over here, number 18. How to get first our, this, the mass. The mass. The mass is simply equal to the density times the volume. What is the density? Okay, 62.4 pound per cubic foot. That is the density of water. 62.4 pounds per cubic foot. Per cubic foot. That is the density of water. Density of water. In metric system, by the way, we have 1,000 kilogram per cubic meter. What do we mean by this? If we have a volume, a cube, I mean, if we have a cube, let's say we have a container that has a cube shape, equal sides. No? Okay. If we have a 1 meter by 1 meter by 1 meter, so length times the width times the height. If you fill up this by a water, this will contain 1,000 kilogram per cubic meter. That is the density of water in metric system. But in English system, if you are to make this as input, this will be input and this will be input. If you fill up this, okay, 1 foot by 1 foot by 1 foot, if you fill up this container, that is a 62.4 pounds. By the way, we will have a conversion so that you can see it. What is the mass? Remember, we have 100 liters. Put here 100 liters. That is times the 100 liters. I said this before that 1 kilogram of water is equal to 1 liter, isn't it? 1 kilogram is equal to 1 liter. So therefore, we may say that 1 cubic meter, there are 1,000 liter. I just reverse this. Take a look here. This is 1,000 liters per cubic meter. That is a conversion. So I just reciprocate this one. So we have 1 cubic meter per liter. So take a look here. This will cancel out the liters. Oh, by the way, let's have some manipulations or conversion here. There are 3.28 feet per meter. Since there is a cube here, we just have to cube this portion. So then we are now ready to calculate this one. Let us calculate this. How many pounds do we have for 100 liters of water? How many pounds? Okay, so we have 62.4 times 100 times 3.28. That is cube. Okay, it's cube. So my answer here is 220.194, isn't it? 220, 220.194. 220.194. Unit. What will be left is just the pounds because the cubic meter here will cancel. This will become cubic meter because of the 3 here, right? Of the 3 here. Take a look here at the 3. There is a cube here. And the cubic foot will cancel also because of the cube here. This will become 3.28 cube, feet cube, meter cube. Okay? That will cancel out. So what will be left is just the pounds. This is the pounds. Okay? Again, what is the question in our problem? So our question in this particular problem is the rise in temperature in degree Fahrenheit. The rise in temperature. By the way, we have given here the energy. The energy is 2.3. Take a look here. 2.3 kilowatt hour. That is a Q, right? That is a Q. The Q is equal to 2.3 kilowatt hour. Okay, we have kilowatt hour. So take note of this conversion in kilowatt hour. There are 3413 British thermal unit per kilowatt hour. Remember that. Okay? So the kilowatt hour will cancel out. Right? That will cancel out. So that will be equal to, okay, so let us multiply 2.3 by 3413. That is equal to 7,849 or 7849. 7849.9. That is British thermal unit. British thermal unit. Okay? British thermal unit. Okay, now we already have the Q. We have already the Q. What is the formula for Q? That is NC delta T. This is the basic formula for Q. Although to be specific, it is the output heat. Since the question here is our delta T, okay, so our delta T now is equal to Q over MC. We already have the Q here. What is our Q? 78, 49.9 British thermal unit. Okay, divided by the mass, which is 20.194 pounds. By the way, what is the specific heat in English system? Okay, in English system, the specific heat is 1 British thermal unit, okay, divided by or per pound per degree Fahrenheit, because this is in English system. Okay? Earlier, we have the 1 kilogram, 1 kilocalorie per kilogram per degree Celsius. That is in the metric system. Remember, in metric system, 1 kilocalorie per kilogram per degree Celsius. That is in metric system. Or simply 1 calorie per gram per degree Celsius. That is in metric system. Okay? In English system, 1 British thermal unit, 1 British thermal unit per pound per degree Fahrenheit. Did you get that? Did you get that? Is that clear? Is that clear? Because this is our C, that is the British. British. Okay? British thermal unit. Okay. Is my accent is good? Is that clear? Okay. So, what is the change in temperature in degree Fahrenheit? The pound here will cancel out. The BTU will cancel out also. Algebraically, this degree Fahrenheit will go up here. Okay? So what will be our answer? This is our final answer. We have 7849.9, then divided by 220.194. We have a value of 35.65 degree Fahrenheit. That is our answer. Okay? Okay, nakukuha nyo ba mga kababayan ko? Nakukuha. Maliwanag tayo. Letter B is the answer. Then let's go to the second to the last problem. Okay. Let's go over here. Okay, you may read the problem while I am erasing the board. Okay. Let's go with number 19. How long it will take a 480 watts, 120 volts water heater to raise the temperature of 1,000 grams of water from 15 degrees Celsius to 100 degrees Celsius, assuming a heat loss of 22%. So we have a heat loss. No? There is a heat loss. How long? Okay, so we have the formula for the output heat. Again, we have MC delta T. MC delta T. So we have 100 grams of water. So put here 1,000, I mean. 1,000 grams of water. And then we have, okay, what is the specific heat? No? So that is 1 gram, 1 calorie, 1 calorie per gram. This is per gram per degree Celsius. What is our degree Celsius here? The difference, no? Actually, the boiling point of water is 100 degrees Celsius. Then minus 15. So that will be in degrees Celsius. Degree Celsius will cancel out and our gram will cancel out also. So we have here our calorie. What is our calorie? We have 85,000. We have here 85,000 calories. That is the output heat. And remember, there is a heat loss of 22%. What is a heat loss? Again, I said before that input heat is equal to the output heat plus the heat loss. That is the heat loss. Okay? We have a 22% heat loss. What about now the heat loss? The thermal efficiency is the output over the input heat times 100%. So we have here the output heat. We already have the, what we call this, the output heat. We have the value 85,000 calories. So we have here 85,000 calories for the, what we call this. This is 85,000. That is the output. Then we have the heat loss. That is 22% heat loss. 22% heat loss. How do we represent that heat loss, by the way? How do we represent that? Okay, so we have here, assuming this is, let us get our input heat. This will become output heat over the heat or thermal efficiency. We have what, let's say a 100% thermal efficiency. We have to subtract it by the 22%. This is 100%. If there is a 22%, we'll come up with how much? 78%. That will be our thermal efficiency. The 78% here. So we have to substitute in here we have 85,000 divided by 0.78. Okay? 0.78. So how much is this? Our input heat. How much is our input heat? We have 108, 108, 974, 974.359. Okay, what is the unit of this? Well, of course, that is in calorie. Okay, that is in calorie. Now, we have the input heat formula. We have the input heat formula here. .24 hour times the time. So this is the input heat formula. Okay? We have here the input heat already. 108, 974, 0.359. 359. That is equal to 0.24 power. What is our power? 480 watts. 480 watts. Then our time. Okay, let us get now our time from this formula. Okay, so the answer here is 945, 945.72 seconds. So, well, our answer must be expressed in minutes. So, in 1 minute, there are 60 seconds. Remember that. Okay? Because the time here in our formula must be in second. So, the second will cancel out. Okay? What is our answer? What is our time? I mean, 15.77 minutes. Okay, that is our final answer. The answer is letter, okay, letter B. Okay, did you get that? Can you follow? Hello, are you still there? So let us say the last number for this problem. Okay, you may copy it first, no? Our last problem. Okay, let's go over with the last number. You may watch this over and over again, no, in the YouTube. Okay, actually, if you really want to master or to learn something, you have to go over. No, you have to make some repetitions. No, you watch the lecture over and over again so that you can master the lecture, the topic, and after viewing it, making some studies, no, you solve at home. You have to practice for you to appreciate our lesson. Okay. Well, if you're just viewing it without any solving in your seats or at home, so please make some practice. No, uh, they say that practice makes perfect. Uh, well, that is our target. No, to become perfect in examination. Okay, but I think it's more realistic to say that practice makes you better. Practice makes you better. Okay, let's go over with our last problem. A process equipment contains 100 gallons of water at 25 degrees Celsius. It is required to bring it to boiling. In 7 minutes, you will boil that water. The heat loss is estimated to be 5%. What is the kilowatt rating of the heater? What is the kilowatt rating? Okay, so we have the output heat is equal to MC delta T. Let us get first the mass. what is the mass? We have here 100 gallons of water. We have 100 gallons. So we have 100 gallons. Okay. So let us have some conversion. There are 3.785 liters per gallon. That is a conversion. No? I saw this in the cover of an ice cream. Okay? In the, you know, the ice cream container, you will see there that for 1 gallon, you will see this. I remember when I was young. So I saw this 3.785 liters per gallon. Okay. Sometimes you just look the nameplate of something, you will learn a lot. You know, when you buy a, what do you call this, LED bulb or any type of bulb, you take a look at the, what do you call this, the rating, no, the specifications are there in the box of the lamp. No? You learn something. No? You just have to take a look there. You have to call this scrutinize. No, you have to read. Okay, let's say you buy an LED bulb or incandescent bulb or a fluorescent bulb or a CFL lamp. You will see there in the box. No, there are a lot of specifications. No, you will see the burning hours, the burning light, no, the corresponding incandescent bulb, no, it compares to incandescent bulb. I saw that in the box of a lamp. Okay, so the gallon will cancel out here. What will be left is the unit of liter. Remember again, 1 kilogram per liter. 1 liter of water correspond to 1 kg. Okay, 1 kilogram. This will cancel out. What will be left is just the kilogram, right? That is the kilogram. So we have 100 times 3.785. Well, it's just 378.5. 378.5 kilograms. Anyway, you don't need calculator. So just take a look here and 100, so 1, 2. So 378.5. So we have the mass. Put here the mass at 378.5. I mean the output heat. What is the mass? 378.5 kilogram. Okay. Then we have 1 kilocalorie per kilogram per degree Celsius. Then what is the change in temperature? It's required to bring it to boiling, therefore 100 degrees Celsius, then minus the initial temperature is 25 degrees Celsius. Again, no? Again, so this will cancel out, the degree Celsius and the kilogram will cancel out. So what will be left is the kilocalorie. So let us calculate again. Okay, so the answer will be 387.5. That is the kilocalorie. But in our problem, it says here that, let us read it again, the heat loss is estimated to be 5%. What do we mean by that? The input heat is equal to the output heat plus the Q loss, the loss heat. But by the way, What is the loss heat? What is that 5%? That is 0.05. That is the decimal, 0.05. Of what? Of the input heat. That should be the case. So there is a 5% heat loss. So we have the input heat. Let us get the input heat. The output heat is 28. What's that? 387.5 plus, okay, let us shift solve this one, 0.05, then input heat. So therefore, our input heat, I'll just put it in here, heat. So we have here, so the answer here is 29881.5 0.57895 to be exact. Okay, this is in kilo calorie. Again, remember the formula. The input heat is equal to 0.24 power times the time. And take note that the unknown here is the power. What is the power? Let us substitute again. 29881.57. Okay, I just rounded this one to 2 decimal places, so make it 58. Okay, so that is equal to 0.24 power times the time. By the way, what is our time? 7 minutes. 7 minutes. There are 60 seconds per minute. Okay. Then let us cancel these minutes. Okay. So let us cancel this in minutes. So we have what? Let us calculate P. We have 29881.58 alpha calc 0.24 alpha close parentheses. So we have 7 times 60. Okay, the answer here will be 296.44. So our P is 296.44. What will be the unit? That should be already in kilowatts. Why, sir? Because this 29,881.58 is expressed in kilocalorie already. Okay? Kilocalorie already. So that is our final answer. Okay? So take a look here. The answer would be letter. In the licensure exam, if there is no exact value, just go to the nearest, which is letter D here. Okay, let's go over again here. Take a look here. Sir, where did you get the 0.24 here? This is the formula, by the way. Where did you get this? That is a conversion. The input heat That is simply equal to, well, the Q is the heat energy or the energy. That is actually the time. That is the power times the time. But the power times the time, no? That is in joule. Again, again, what is the conversion? So that you will come up here with calorie. Because this power times time is in joules. We said that 1 calorie, there are 4.186 joules. There, no? So the joules will cancel out here. So you will come up with calorie. So what is 1 divided by? So that is 1 over 4.186. 1 divided by 4.186 equals. That is actually 0.2388915432. See? So rounded it off, it will become 0.24. This will become 0.24. 1 divided by 4.186 joules. Okay? Did you get that? So that is 1 calorie is equivalent to 4.186 joule. Okay, so remember this conversion that we taken up. That's very important. So we have to take note some constants or conversion, no, in our calculation. Okay, so if you know those things, so that is easy. That will be easy for you to solve this problem, no? Okay, so with this, I should say thank you very much, no? Thank you very much, no, for those for our viewers. So tomorrow, 9 a.m. Philippine time, so we have the continuation of direct current circuit. I'm inviting everyone to attend to our Zoom class, no? It's better if you will uh, go to our Zoom class, no? Okay, by the way, so to our Filipino audience in our Zoom class, are there any questions? Any question? Marlo, do you have any question regarding our discussion for today? Marlo, what is your question?
Does the value of specific heat serve are constants or depending on the type of substance used in the problem?
The specific heat, that specific heat is the specific heat for water. We have to, for a different substance, you have different specific heat. Actually, it is not being covered in our major. It is being covered in the engineering sciences, to be specific in thermodynamics. Okay? So, although I'm not the expert of that subject, we have an expert in thermodynamics. His name is Engineer Mark Anthony Dionisio. So, I think we already uploaded his lecture about thermodynamics. You better see it. I would advise you, you can view that in YouTube. Okay? Our best lecturer in engineering science. So, you may view it in our YouTube, in my YouTube channel. Okay? Okay, more question? Mark of PUP, do you have any question?
None so far, sir.
Okay. So, no more question to our Filipino audience. Well, actually, many of our viewers are in Facebook or in our YouTube Live. So, may I invite everyone to join with us. No? So, please join with us, no, with our live discussion so that you will receive a certificate from our review center. No? This is very helpful to you. when you graduated, you will apply for a job, no? This is a plus factor if you have these certificates that you attended this long lecture. This is a very long lecture actually, the study of electrical engineering the Filipino way, no? Okay, so to our foreign nationals or to our foreign friends, no, to non-Filipino audience, no, thank you very much for watching. Actually, I'm doing this in English, no, although it's really hard for us, no, because we are not, I'm not that fluent in speaking the language, no. Although Philippines is that is our second language, no. But we have this what we call the modern language of Filipinos is the Taglish. You know, that's a combination really, no. It's quite for us to this to make it a pure uh, Tagalog word, no. So it's really we have to take note of the some word. We have to copy paste this link, this English word. No? Okay, so we are doing this, no, for you guys, no, for our students around the globe, all over the world. No, I'm inviting everyone to watch our live streaming, no, on YouTube. No, this is 3 times a week. Well, actually, we still have our pre-webinar, no? These are special topics in electrical engineering. Uh, Tomorrow we have the direct current circuits part 2. We will start there with direct current series circuit. Tomorrow our topic is series circuit. So if we can finish it, we can go to a parallel circuit. And then on Wednesday we have a special topic. This is a special pre-webinar. Okay, you can watch this also in YouTube. Live streaming. This is a power system engineering. This is a higher subject. No, I will try my best to speak in English so that everybody may understand in the world. Okay, so not only in the Philippines. So it's a very nice topic about power system engineering. So it's more of a discussion. No, I will discuss to you this the basics of power system engineering course or profession. No? You will see that. Okay, and then on Friday, Philippine time, still 9 a.m. up to 12:30 or 1 p.m. No, that is Philippine time. So I'm inviting everyone. And then please share this. Please share. Please comment. Please put your comment in the comment section of our YouTube channel or this particular video. Please put your comment. Okay, and then to all our Filipino audience, so please do not leave yet. No, I'll say something with you. Okay, so well, that's it for today. Thank you very much. No? Kawer pa, maraming salamat. Thank you very much to everyone. Keep safe. God bless you all. Okay na?